students, this is Mira and welcome back to my channel. Today we will solve another numerical on rectilinear motion. So let's see the problem statement without further delay. A car is traveling at speed of 72 km per hour. Suddenly, the driver observes that the traffic signal at cross section 300 meters ahead of him is showing red light. The remaining time of red light is 20 seconds before it turns green. If the driver wants to pass the cross section without stopping to wait for it to turn green, determine the required uniform acceleration of car. Also find out the speed with which the car crosses the intersection. This is the problem statement. Now before we begin, let's see the type of problems we may face in case of rectilinear motion. There may be simple problems of variable acceleration, or let's say no uniform acceleration is mentioned, and they can be easily solved using differentiation, integration and some general equations. There may be problems of uniform acceleration, and these are the equations for this case. These equations will be used if only acceleration or deceleration is the point of concern. Also, there can be problems of erratic motion where the motion parameters are not continuous. In a single problem, acceleration, deceleration, constant speed, etc. are included. For this type of problems, xt, vt or at graphs will be plotted and solutions will be derived from graphical methods. Now let's see out of these three which type of problem we are having. So the car is traveling at certain speed first, then accelerate uniformly for 300 meters and then pass the intersection. So we are interested in the 300-meter journey only. What the driver do before and after that time is none of our business. And during that period, car is accelerating uniformly. So we will use the equations of uniform acceleration here. Now let's see what is given data and what is to find out. The initial velocity of car V0 is given, that is 72 km per hour. The signal is 300 meter ahead, so x is equals to 300 meter. In previous problem we solved, there were two vehicles with two different sets of parameters. So whenever you have two different moving bodies, you can somehow compare the parameters and find out unknown values. But here we have only one car and a signal which is not a moving body. Except it is moving and giving space to traffic, but we poor muggles do not observe properly. So the point is, when there is only one moving body, you have to extract data from some hints given in problem statement. In our case, it is given that the signal is going to show red light for next 20 seconds. So our driver need to change the velocity such that car travels the 300 meter distance in this 20 seconds. There is no need to stop at crossing, and as soon as the signal turns green, he or she can cross the intersection. So time t is equals to 20 seconds. What we need to find out is uniform acceleration A and speed with which the car crosses the intersection, that is final velocity v. So first we will convert the initial velocity in meter per second units. So 1 kilometer is equals to 1000 meter. So multiply 72 by 1000 and 1 hour is equals to 3600 seconds. So divide it by 3600. So now our initial velocity is 20 meter per second. Now we have three equations available. For first and third equations, v and a, two unknown variables are there. But in second equation, only missing data is acceleration. So begin with second equation. Simply put all the values and we get A is equals to minus 0.5 meter per second square. Negative sign indicates deceleration, so driver has to reduce the velocity by 0.5 meter per second constantly. Now to find out final velocity, you can use any one of the remaining equations. Both of them include V. So let's select the simple one. V is equals to V0 plus AT. V0 is 20 meter per second. We just calculated A, that is minus 0.5 meter per second square, and T is equals to 20 second. Put all the values and final velocity is 10 meter per second. Eventually you can use the other equation too. Here value of V0 and A is as it is. X is equals to 300 meter. Put all values and you will see that we get V is equals to 10 meter per second using this equation too.